So welcome back. And can I get a thumbs up or something so people can hear me? Yes, thank you. Wonderful. Okay, so thanks for coming to the session on methods in web-based experiments. I'm Becky Gilbert. I'm a postdoc in Matt Davis's group. And I joined the unit a few years ago to, in part, to put together a system for running web-based experiments here at the unit. So if you hear people talking about the JTOS or YATOS server, that's what that is. It's a server-side system that we have at the unit for hosting web-based experiments. And sorry. Right. And then that system can host any kind of experiment written in the languages of the web, which is JavaScript, HTML, and CSS. And we also tend to use a JavaScript library called JSPsych for writing the code that runs the experiments. So you might hear me focusing more on that in part of my talk. And that's just because that's kind of what I specialize in. But there are other ways to run experiments or other systems and services and tools, but I'm going to be focusing a little more on that. And what I'm going to start talking about for today, I'm going to talk about headphones tests. So headphones tests are something that I think aren't just useful for people doing auditory perception research, but really if you're using any kind of auditory stimuli, it might be a good idea to think about using a headphone test at the start of your experiment. And this gives you a way to kind of see whether, of course, people are wearing headphones, which is going to be useful just for blocking out background noise and helping people focus in what might be a more distracting environment. And they also kind of serve as an attention check because you're asking your participants to do something that you can't, you're not there to see that they're doing it. So it's kind of useful to see if people are reading your instructions, are they following your instructions? So the headphones test that we've been using is this one called the antiphase test by Kevin Woods and colleagues, published back in 2017. And this test has worked fairly well. It's not perfect, but we've been using it and it works okay. And it's very clever. I think it's the only one I've known about up until now. And the way it works is that on each trial, you present a set of 3 tones. And one of those, the task is to say which of the 3 tones was the softest or the quietest. So one of the tones actually is the softest one. And then the second one here is actually the loudest and always sounds the loudest. And the third one has a phase shift between the left and right channels. And so what happens is over headphones, it sounds, as you can see, it's got the same amplitude as the loudest sound, and it sounds just as loud. But over speakers, those left and right channels have a chance to mix together before they reach the ear. And so they cancel each other out to a certain extent. And so when you're listening in a free field over speakers, then that last tone will sound more quiet. And so that becomes the foil response, which you're more likely to make if you're listening over headphones. So, like I said, there are some kind of some practical issues with that test. And there have been some other researchers who have just recently come out with a new headphones test, which I wanted to let you know about. So this is based on Huggins pitch perception. And this paper is out in, it's a preprint in bioRxiv. So the trials are kind of similar in that on each trial, you hear 3 different sounds. In this case, they're bursts of white noise. And in one of the noise bursts, there is a frequency band that's phase shifted by 180 degrees. And so what it sounds like over headphones is you get this perception of a tone, and that's kind of embedded in the white noise. And then the other 2 sounds are just white noise. So the task is a detection task. There's no discrimination. You're just saying which of the 3 sounds contained a tone. And I think the nice thing about this test is that it's actually, I think, a really striking effect from having done it myself. So I would encourage you, if you're interested, to go to the author's website. They shared all their code, and they put some demos online as well, so you can test it out. The first link they have there is the Huggins pitch test. Then they also have an implementation of the antiphase test and a third one as well. And I just want to point out some comparisons between the antiphase and Huggins pitch. And this figure is from their paper. And we have antiphase on the left. So the way that this test works really depends on the left and right channels mixing in this kind of free field before reaching the ears when it's played over speakers. And what that means is it's possible to pass this test if you're getting all of the input or one of the input from just one of the two channels. So they're not really mixing equally before you hear them. So that might mean you're listening with just one earphone or headphone on. It might mean that it's sensitive to your head placement and the placement of your speakers in the room. And of course, if one of your speakers is broken or something. So anything that affects the kind of that mixing of the two channels. And by contrast, the Huggins pitch test kind of nicely gets around that problem, because you can really, I think you can really only detect the tone when the left and right channels are presented separately to each ear. So the audio perception researchers can help me out with this if I'm wrong, but I think it's not possible to pass over speakers or when you're just getting input from one of the two channels. So another thing to point out, this is again from their paper, they've compared performance on these two tests when people are listening with and without headphones. First of all, you can notice that the performance on both of these tests really isn't perfect. So on the x-axis, we have performance out of 6, and 6 is all the way on the left. So that would be a perfect score on these tests. Now, when people are wearing headphones, which are the darker colors here, about 70% of people pass the antiphase test and about 80% pass Huggins pitch. It's good, but it's not perfect. It should be closer to 100%. And then when people are not wearing headphones and listening over speakers, you get some people who will still pass your test. But with the Huggins pitch test, you get a lower percentage of people who get that perfect score. And then another thing to point out is that the distributions of scores when people are not wearing headphones are different between the two tests, because the antiphase test has this foil present during the task. And so you can actually see this distribution of scores that's lower than chance, which is 2 out of 6 here. Whereas the Huggins pitch, if you're listening over speakers, you just don't hear the tone. So you're just going to be guessing on each trial. And so this is why you get a distribution around 2 chance. And I think it kind of changes the test in an interesting way, because with the antiphase test, when you're listening over speakers, it does kind of feel like you're doing the task, because you can detect that one of the tones is quieter and you're making that response. And of course, you're probably responding with the foil. Whereas with the Huggins pitch test, you really just can't do the test at all because you're not detecting a tone. And so that's kind of a clue that something's gone wrong. So maybe something to think about when you're choosing these tests. Okay, so I'm going to move on now to talking about audio responses. So this is recording spoken responses from your participants over the internet. And this is a case where it's really nice that we have a system for collecting data with our own server at the CBU and storing the data in-house, because spoken responses are personally identifiable data. And so they do have to be treated in a more kind of secure way as much as possible. So I became interested in this because there were some people at the unit who wanted to do some audio recording. In particular, there was a master's student in the emotion group last year who, because of COVID, had to stop all of his in-person testing. He was doing a master's, so he was on a strict timeline and had to move everything online. And he had a verbal fluency test that it's really something you can only do with spoken responses. So we started working on implementing this in JSPsych, and so we have a set of plugins you can use if you're interested in this. Right now, they're all in my own GitHub on my JSPsych fork, and they're in a branch called Audio Response. But you can just go to that link there, and you'll get all of the files with some examples and documentation. And at some point soon, when I fix up the documentation, it'll go into the JSPsych library. So I mentioned Chase, he did the verbal fluency test. Claudia is working with Francesca here at the unit, and they're using this for a picture naming task. So they're testing native Chinese speakers, and who are learning English. And so this is a vocabulary test where they're naming the pictures in English, which is a nice way of testing somebody's vocabulary in a non-native language. And Dorian, who'll be talking later today, is planning an online version of Stroop, a variant of Stroop, and he's interested in comparing effect sizes with keyboard versus spoken responses. So in Dorian's case, we also needed to know whether we could get reliable response times from these recordings. So working with David Hayes at the unit, we were able to put together a system for testing this. And this is something that's in progress right now. We're currently working on, and we've got a GitHub repository for it if anyone wants to follow along. There's not much there at the moment, but so what we're doing then is we're having the browser show an image on the screen, and that will trigger a microcontroller that produces a tone, and that with a known delay. So that becomes our simulated spoken response. The browser records that tone, and then we can look at the audio files that we get from these recordings and see whether the response time measured from the audio file matches up with the known response time. So that's work in progress that I'm hoping I can update you on soon. Okay, so that's pretty much all I have for you, but I want to also just share some demos of what myself and other people in the unit have been working on lately, just so that you know what people are doing. And if you want to do something similar, you kind of have somebody you can go and ask for code and for help. So you're not reinventing the wheel here. So one thing that we're working on is setting up a system for running multi-session training studies on the Yato server. And this is something that right now I'm working on with Polly, and she's actually got a set of games that were developed externally, but they're written in HTML, CSS, JavaScript, which means we can host them on our server. So I just did some modifications to host them on our Yato server. And then what I did is I just kind of created like a homepage that welcomes the participant, and it knows things like what kind of training they're doing, how many sessions they have to do, which session number they're on, and that kind of thing. And then what it does is it sends them off to do the appropriate task. And if it's adaptive, then it also needs to know the appropriate difficulty level for that participant. And then after that task, it kind of sends the person back and updates all their information, for example, with a new difficulty level, and marks that task as being done and so on. So I can imagine that other people might want to use something similar, even though it might look very different from this. I'll just show you. Hopefully you can see my browser. Somebody tell me if not. But this is kind of what the homepage looks like. Great, thumbs up, thanks. It kind of knows, okay, you're on session 1, you're about to do session 2, and then you click start, and it takes you off to this game, and then it sends you back. So I think what I'm hoping is that we'll have kind of a template for doing this, so that when somebody else wants to do it, obviously you change the way it looks and the content, but the kind of whole way that things talk to each other and the way that you can enter parameters and that sort of thing has already been done. Speaking of training, Joe Rennie has done training studies without all of this help. He's had to just kind of figure it out, and he's done a fantastic job. And so right now he's doing a change detection training where he shows arrows of different colors and orientations, and then the participant gets cued, and they have to say whether the arrow, which direction it changed color or orientation. So if anyone wants to do something similar, he's sharing his code, and he'd be a great resource for that. Right, another thing we've done is Lydia came to me about doing a dial response plugin because she moved a task online where it's kind of a dot motion task. You have a bunch of dots moving in different directions, and she needed her participants to respond with an orientation. And she actually found this this JavaScript library that does that for you. So that's great. And then all we had to do was turn it into a JS-like plugin. So now we have a JS-like plugin available for this. It's got a bunch of parameters. You can change the way it looks. So you can have it finish with an enter key or a button, and you can do partial circles and add the numbers and all of these things. And I think this is what hers actually looks like. But anyway, so then, yeah, if you want participants to respond with an orientation or a color on a color wheel, that might be useful. And the GitHub repository is there on the screen. And Estella has been doing some fantastic things in Tom Manley's group. She put together a whole JS-like plugin for doing cancellation tasks where you can specify target and non-target images and where they go on the screen. And then the participants either click on them with the mouse or touch them if you're doing it on a touch screen. And she can show visual feedback about whether the response is correct or not. And she's also done this spatial neglect task where they show images in specific locations on the screen for specific durations. And then they're showing a video in the background. And so the nice thing about this is they can just swap out the video to get different kind of context to see how that affects attention. And then participants respond to these images that come up and say whether they see something on the left, right, or both sides. And again, this is a plugin, a JS-like plugin, so it's all parameterized and it would be very easy to reuse if you're interested. And I think that's about, oh, and we've got in Bob's group, Andrew Harland and Alan have been working on their stripes task where they present 3 different sounds, and the task is to select the odd one out. And they're doing this so that it runs on mobile phones. So they've got their kind of mobile friendly task, and they're using a staircase procedure to control the difficulty. And they've really jumped in and taken over the plugin development and done a great job with it as well. So hopefully that's useful to some of you who might be interested in those things. And hopefully we have time for questions. Thanks.